With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, so let's start solving the question, and we have to find out the product P in this reaction, right? So this is a series of reactions, and in this particular reaction, right, so we have to find out this product, right? Here we have a reactant that is ethine, right? So ethine molecule, and it is treated with first LiNS2, right? And then it's alkyl halide, right? So after this a product A is formed, right? So this A is formed, right? So when this A is treated with HgSO4 and H2SO4, product B is formed, right? And after this, when this is treated with NaBH4, right? So which is the reducing agent, right? So which results into the formation of product C, right? So after this, we get a product P after treating with concentrated H2SO4, right? So let's start to solving it, right? So first we have a molecule that is ethine molecule, right? So let me write here that is ethine, right? So this is our ethine, right? And as we know that the hydrogen of the ethine molecule, right? So hydrogen of the ethine molecule is very acidic, right? So since it is acidic, right? So it can be abstracted by base, right? So that's why we have used here base, right? So that is LiNS2, right? So that is LiNS2, right? So this is LiNS2, right? So now you can see here this has a negative charge, right? So this will abstract this proton, right? So this will abstract this proton, and there is a formation of nucleophilic species, right? There is a formation of nucleophilic species, right? So now you can see here this nucleophilic species is treated with alkyl halide, right? This nucleophilic species is treated with alkyl halide, right? So now you can see here this alkyl halide is like this, right? So this is our alkyl halide, right? So now you can see here the alkyl halide is our like this. Let's say this is our CH, right? So let's say this is CHCl, right? So this is our CHCl, and here this is methyl group, right? So this is our methyl group, right? And this is our CH, right? And CH3 whole twice, right? So now you can see here this is our CH3 whole twice, right? So now you can see this is secondary alkyl halide, right? So after this, when this nucleophile attack on this electrophilic center, because this is our electrophilic center, right? Due to this chlorine, right? So after this, we'll get a product like this, right? So we'll get a product like this, right? So this is our product, right? So CH3, CH, right? Here you get C triple bond CH, right? C triple bond CH, right? And here you will get this is our CH, right? And this is CH whole CH3 whole twice, right? So now after this is our product A, right? So this is our product A, right? So now when we react with this product A with the H2SO4, right? So or HgSO4, right? So let me write down here that is HgSO4, right? So HgSO4 and H2SO4, right? So since this reaction will according to the Markovnikov rule, right? So that means negative part of the OH negative ions will go to that carbon where there is less number of hydrogen. That means here, right? So and the reaction will be look like this, right? So you can see the reaction will be look like this. That is CH3 here. That is CH, right? So this is our CH3 whole twice, right? And this becomes C triple bond C, right? So here this becomes H and this H, and this becomes OH, right? So now further it is treated with, since it is a, you can see it, since it is enol form, right? So it can be converted into keto-enol form, right? So keto-enol form, that means tautomerization takes place, right? So that means tautomerization takes place here, right? So here what will happen? This enol form is converted into keto form, right? So now the keto form will be look like this, right? So you can see this is our CH3, right? And this is CH, right? And this is CH3 whole twice, and this becomes keto form, right? So this becomes keto form, and this becomes our CH3, right? So now this is our product B, right? So this is our product B, right? So let's say this is our product B. So I'm just writing it. This is our product B, right? So this B product is treated with NaBH4, right? So which is a reducing agent, right? So which is a reducing agent, right? So this is our NaBH4. So it just simply convert the ketonic part, right? So this is our ketonic part, right? So this is our ketonic part is simply convert into its COH, right? So the reaction will be look like this. That is CH3 here, that becomes CH here, that is CH3 whole twice, right? And it becomes CHOH, right? So it becomes CHOH, and this is our CH3, right? So now after this is our product, this is our product C, right? So this is our product C, right? So this is our product C, right? So now what will happen? This is treated with concentrated H2SO4, right? So this is treated with concentrated H2SO4, right? So concentrated H2SO4, right? So what will happen from this? H plus ion will come out, right? and this will be affected by this lone pair of this OH negative, OH, right? So you can see this, there is a formation of OH2 molecules, right? So water molecule, removal of water molecule, right? So you can see this will be look like this, that is CH here, right? And this becomes, right? So you can write like the, write down this is CH, right? CH, and this becomes OH2 positive here, right? And this is our CH3, right? So this is our CH3, right? And this is our CH. This is our 2-methyl group, right? So these are 2-methyl group, right? Now, since we have heated it, right? So since we have heated it, right? That means this water molecule remove out, right? So here, so what will happen? There is a formation of secondary carbocation, right? So there is a formation of secondary carbocation, right? So the secondary carbocation formation will be look like this. That is CH3 here. CH3 here, that is CH, right? And it becomes CH. This is our methyl group, right? So these are 2-methyl group, right? And this becomes our secondary carbocation, right? So this becomes our secondary carbocation, and this is our methyl group, right? So now you can see here, this is our secondary carbocation, right? So now what will happen? This hydrogen, right? So what will happen? There is 1,2 hydride shift takes place to make a tertiary carbocation, right? So to make a tertiary carbocation, right? So here this will go like this, and there is a formation of tertiary carbocation, right? So I can write down here 1,2 hydride shift, 1,2 hydride shift, 1,2 hydride shift, right? So after 1,2 hydride shift, there is a formation of tertiary carbocation, right? So because tertiary carbocation is more stable, right? So actually what will happen here, that becomes CH3, right? So this becomes tertiary carbocation here, that is our CH2, right? So this becomes CH2, and this is our CH3, right? And this becomes our CH, right? So these are 2-methyl group, right? So these are 2-methyl group, right? So now, since we have used concentrated ester support, that means it will act as a catalyst. So here you can see this to make this. So here there is a substitute alkene formation takes place, right? So this will remove out, right? So here proton will remove out, right? So what will happen? So in this particular reaction, the product will be look like this. So here this is carbon here, right? So this is carbon, and this is our CH2, CH3, right? And this is our methyl group here, and this become double bond here, right? And here minus H plus ion, you can write down like this, right? So and these are 2-methyl groups, right? So these are 2-methyl group, right? So now you can see that this is our final product P, right? So this is our final product P, right? So this is our final product P, right? So let's check our option. In option, you can see this. We have got the substituted alkene, right? So we have got the substituted alkene. That means, and one carbon, there are 2-methyl group, and one carbon, 1 methyl and 1 ethyl group, right? So let's check it, right? So now you can see here at this particular carbon, there is no methyl group over it, right? So this cannot be our answer, right? Here, right? So one carbon, 2-methyl group, 1 methyl and 1 ethyl. Yes, this is our correct answer, right? And here, if you check it, so you can see here there are 1 methyl and 1 hydrogen, right? So this cannot be our answer, right? And here is also there is no 2-methyl and 1 carbon, right? So that means this is not our answer, right? So now we are left with the correct answer, that is option B, right? So this will be the correct answer, and this is our major product, because this is most substituted product, right? So hope this answered your question. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.